Okay, so in this lesson, we will know what a magnetic variation is, what causes it, and why is it important, And lastly, in this lesson, we will also know how to calculate for the magnetic variation. All right, let's begin. So, as we all know, we have magnetic compasses on board ships. So, back then, at the earlier times of seafaring, so seafarers would normally rely only on magnetic compasses to point to the right direction. Okay, so a compass generally will always point north. Okay, so that's why it's called a compass, right? However, since this is a magnetic compass, so this can be influenced and this can be affected by a lot of things. All right, so what are these things? You know, what are these things? Okay, so we have what we call a variation and we also have a deviation. So what's the difference between this two? Okay, so generally both of them are errors when it comes to compass reading. Okay, so these are errors in the compass. So let's talk about variation first. So variation, the other name for this is magnetic declination. Okay, so basically it is the difference between the true north and the magnetic north. All right. So we have already discussed about that in the previous lesson. Okay, so variation is the error in reading a compass bearing due to the Earth's magnetism. Okay, so for variation, guys, so this is the error that is caused by the Earth's magnetism. So again, you've also read about this one, Earth's magnetism, in the previous lessons. Okay, so naturally, Earth has magnetic fields. No? And it sometimes it's too strong. It actually varies in different areas. So but still the Earth's magnetism can affect the compass reading of the ship, and that is what we call the variation. Okay, what about the deviation? So actually, guys, it's almost the same. However, this one is caused by the ship's magnetic influence. So since the ship is made of metal, right? So and metals are always influencing magnets. Okay, so since the ship is made of metal, so normally and naturally, the compass is affected by it. And that's what we call the deviation. Okay. So in other terms, so basically, instead of the compass pointing north on the true north, so it actually deviated because of the magnetic influence of the ship. All right. So that's the difference between variation and deviation. Okay, let's proceed. All right. So here, as what I've explained in the previous lesson, so here we can see it clearly. So we have the true North Pole, that's the true north. And then we have the magnetic north pole, which is the magnetic north. Okay, so all in all, we have three norths that are very useful for seafarers. The third one is the compass north. Okay, so as you can see in this diagram, both of them are actually far from each other. All right, so let's continue. Okay, so variation, it is either east or west, no? So ang apelido niya, east or west ra yun. It's not north or south. East or west ang apelido sa variation. So ang east variation or declination, it's considered as positive, wherein west is considered as negative. Okay, so more on that later. Okay, because that will be helpful during the calculation. All right, thank you. Now let's proceed to the next one. We have Okay, so now, how relevant is this? Like, where as seafarers, no? So as the cadets, for sure, soon enough you will become officers on board. So this is very important for all of you. So, ang saon pagpangita, how will you find the variation? So actually, guys, this variation value can actually be found on the compass rose. So we have something that we call a compass rose. I hope that You will not think of a really, a real rose. No, this is not a plant. Okay, this is actually a graduated marking that you can easily find in the traditional magnetic compass. Okay, so this is basically the meaning of the compass rose, and sometimes it's actually called a wind rose. However, these days we call it the compass rose. And also, in modern times, the compass rose can be found in a lot of navigation systems on the bridge. Now, it can be found in the charts, so especially in the ECDIS, that's the electronic chart. And then it can also be found in the GPS and other equipment. All right. But what does it look like? All right. So this is what it looks like. So this is what we call a compass rose. Okay. So this is what we call a compass rose. All right. So who can guess where the variation is? Anyone? Just kidding. Okay. So the variation is actually in the middle part. So you can see here. So you can see here this one, this value. This is what we call a compass. This is what we call a variation, and this the whole graph is called a compass rose. Okay, so this value is called a variation. So we can always identify the variation because it is always preceded by this arrowhead. There is always this arrowhead. So if you go through this line, then you can see the value of the variation. Okay, so you might have noticed that there is a star. So what is this? So this star is the symbol for the true north. Okay, that is the true north. So sometimes we actually we actually refer to the true north, or we actually refer to the north star, which is what we call the polaris. No, well, we call it the polaris, the north star. We actually refer it to the um, the location, or the guide of where the true north really is. Okay, all right, so let's continue. So aside from this symbolic figure or representation of the compass rose, there are also other versions of the variation, which can be seen in the next page. Okay, like for example, this one. This is another way of representing the variation. Although this is the older version, but I just want all of you to be aware that there are different types of representation of the variation. Okay, so let's go back a little bit. So this is the modern one, and this is the older version. All right. So what are all of these? What are these numbers in this year? Like, okay, what do you think are these? All right, so let's find out. Okay, so here is another example of a compass rose. So I think all of you know exactly where the variation is. The variation is here. Okay, let's continue. Okay, so this is the same picture. I just minimized this one. So this is the picture of the compass rose, and if we zoom in to the variation, this is what we can see. So how do we read it? So we read it as here. Look at here, 4 degrees, 15 minutes west. Okay, ayaw kalimti ang apelido. Do not forget the sign. Okay, the sign is west. All right. So, but what about this one? Is this a year? What are these? Okay, let's find out in the next part. Okay, so this is how we read the variation. Okay, so in the first part, we have the variation, which is 4 degrees 15 minutes west, and we also have the year. So this is actually the year in which the variation was taken. Okay, so this was the year that the variation, because guys, this will be provided to us when the vessel will buy a chart. So automatically this will be provided also, and this will be refreshed yearly. Okay, So this is the year again when the variation was recorded. Okay. So and then what about the this one? 8. Actually, guys, that apostrophe that means minutes. 8 minutes east. So please do not be confused. Do not treat it as like a minute time. No, it's not the same. It doesn't have the same meaning. Okay, this is a different minute. All right. So we also, that's what we call the arc of time. Okay, it's not the same with this one. All right. So again, um, we have here 8 minutes is the east. That's the annual change in variation. All right. Let's continue. Okay. So again, guys, as what I've said earlier, variation actually changes a lot. That's why we. That's the reason why we're doing calculations. No. So that's why we're doing calculations because it's changing frequently. So it doesn't only change according to its position. No, not only according to its position, but it changes over time. That's why we have a year here, so we can have a reference of when this variation was taken. Okay, so this 2009, was still from 2009, and now it's already 2020. So it's a very very big difference now because every year the variation will change by 8 minutes east. So this is the annual change in variation, no? Every year. So just imagine we're already 2020 now. How many years is that? That's like 11 years already. Okay, so let's continue. So again, variation changes in position, and also it changes over time. Okay, so why does it change over time? Okay, so you can see here, this is caused because the position of the magnetic north pole moves in a small circle around the true north pole over hundreds of years. So it doesn't stay in one place. It changes all the time. That is why we have to correct, or we have to calculate for the correct variation. Okay, so again, the annual change is indicated by the figure in brackets. So, unsa ni ang brackets? So the brackets are this one. This is the brackets. So actually, it's here. It's a close and open parenthesis. Okay, so but this is the annual change in variation. This is how it will be represented in the compass rose. Okay, so let's continue. All right, now, so how to calculate for the variation? Because we need the variation to be, to be updated all the time so that we will know exactly where our compass is pointing. you know okay, so all right, so now before we calculate the variation, there are two things that we need. So what are these? So first, we need the variation itself, the data that you can see in the compass rose, and we also need the annual change in variation, again, also in the compass rose. So the annual change is the one with the close and open parenthesis. Okay. All right, so let's continue. So let's take a look at the steps on how to calculate variation. So these are the steps. So we have two steps. The first one is to get the total change of variation first. So you have to get the total change. And then after that, we will calculate the variation of the desired year using the total change of variation. Okay, so these are the two steps. Do not forget about this one. Okay, so let's continue. Okay, so let's have an example. First example. All right. So yeah, same with earlier. Same with the variation that we have seen earlier. So let's use it as an example. No. So the variation here is 4 degrees 15 minutes west, 2009, and the annual change in variation is 8 minutes east. All right. So let's say that we are trying to calculate for the variation for this year, for today, for 2020. No? Okay, let's see. So let's begin with the first step. Okay, again, step one is to get the total change of variation. All right. So Now we have here 2020. This is the year, current year that we have. And then the 2009 is from the given, no? From the variation. So that was when the variation was recorded. So that's from the given. All right, so let's subtract it first. So how much is it? 2020 minus 2009. So we have 11 years. So it's been 11 years since the variation was recorded. Okay? So that will be our answer, 11 years. Now, let us apply this to the annual change because again guys, diba, this one is the annual change. So every year it will change. So for 8 minutes east, so this one 4 degrees 15 minutes west, this was taken in 2009, right? And then every year since 2009, it's been changing for 8 minutes east per year. Okay, so let's multiply 8 minutes east to 11 years. All right, so here we have it. 11 years times 8 minutes east, how much? So that is equivalent to 88 minutes east. Okay, so 88 minutes east, that's the total change of the variation since 2009. No, that's for the 11 years. All right, so now how can we apply 88 minutes? No, supposedly we will apply 88 minutes to 4 degrees. But 4 degrees and minutes, this is in degrees, this is in minutes, we cannot do something about it. I mean, if you will calculate agad, it it will not result to a correct value because they are not having the same unit of measurement. This is degrees, this is minutes. So how do we convert minutes into degrees? All right, so this is how. This is a guide for you. So 1 degree. So this is not to be confused with the temperature. Okay, this is not the temperature. This is a degree, an angle. This is an angle. Okay, so 1 degree is equivalent to 60 minutes. Guys, these are the symbols. Okay, 60 minutes, and then 1 minute is equal to 60 seconds. Okay, so now how do we convert 88 minutes into degrees using this table? Okay, so exactly. So we have to divide 88 by 60 minutes to get the degree. All right, so let's continue. So 88 minutes east divided by 60 minutes. And then how much? That will be 1 degree 28 minutes east. Okay, so if you try to calculate it, if you try to divide 88 by 60, then the actual the actual result will be 1.46666. Okay, so all you have to do, since this is degrees already, all you have to do is to remove the 1 because it's already in degrees, so minus 1. Okay, hold on, I will show you how. Okay, so diba, if you calculate it, um, 88 divided by 60, so this will be the result. So all you have to do, this is actually in degrees already, guys, degrees Nanestia. So all you have to do is to deduct the whole number. The whole number is 1, right? So let's minus 1. So all we have here remaining is 0.4666. Okay, so this is in degrees also. So the 1 is already in here. This is the 1 degree already. And then now let's convert this because we, guys, as much as possible we have to avoid decimals in this variation. Okay, we don't need to use decimals, so we have to convert this into a whole number. So how can we do that? So we have to convert this again into minutes. So let's change it to minutes again. So again, how many minutes in 1 degree? So we have 60 minutes. So all you have to do is to reverse, no? We have, this is degree already, so let's multiply by 60. And there you have it. So 28. And then this one you bring down, you put it here. That's 28 minutes east. Okay, very good. So I hope you get it. All right. So now let's proceed to the next step. We're not yet finished. Okay. So what we did was only the step one. So we only solved for the total change in variation. So this is the total change in variation for 11 years since 2009. No? So this is the total change. Okay. Now let's move on. Okay. So now for step two, we have to calculate the variation of the desired year using the total change of variation. So we already solved for the total change, then we have to calculate na sa atong variation for 2020. So please do not forget this rule. Same direction or sign, so you have to add it. So what is direction or sign? So mo ni siya ang if this is the west or east, okay? So if it's west and west, then you have to add it. If it's east and east, add again. But if it's east and west, then that's different signs, so you have to subtract it. Okay, so do not forget about this one. This will be very helpful in the next slides. Okay, next. All right, so now let us solve for the number two. So this will be the last step. Okay, so we have here 4 degrees 15 minutes west, and we also have 1 degree 28 minutes east. So what are these? So again, this one, 4 degrees 15 minutes west, this was the given earlier. Muna ang given sa atong problem. So this was the variation taken 2019. 2009, sorry. Okay, this is in the compass rose. All right, so that is the given. So what about 1 degree 28 minutes east? So this is what we solved in step 1. No? So this is the total change in variation. So um, this is the this is what we get. This is the result from step 1. Okay, let's continue. So again, what was the rule? Same direction, you have to add. Different direction, we have to subtract. So now, what do we have here? We have west and east. So we have to subtract. Okay, so let's minus. So 4 degrees 15 minutes west minus 1 degree 28 minutes east. How much is it? So it's equal to 2 degrees 47 minutes west. So how do you solve this one? So first solve in the minutes area. So unahan niya siya solve. And then for example in this case, 15 is smaller than 28. So what are you going to do? So you will have to borrow from 4. So you will get 1 degree from the 4 and add it to 15. So 1 degree, so let's add it to the minutes. So it will become 60 degrees plus 15 minutes. Hold on, I will get the calculator again. So again, we cannot solve it right away since the the top portion is smaller compared to the lower portion that we will be subtracting. So all you have to do is to borrow 1 degree from 4 and then add it to 15 minutes. So 1 degree is equal to 60 minutes, right? So all we have to do is to add it to 15 minutes. So now it's 75. So 75 minus, how much is this? 28. 28. And then we have here 47 minutes. So that's it, 47 minutes. All right. So, and now let's go to the degrees portion. So since we already took 1 degree from here, so it's 3 na lang this is only 3 degrees now. So all you have to do is to minus 3 with 1. So the answer is 2 degrees. Okay. So is this the answer now? Yes, exactly. This is the answer. So this will be the variation in 2020.